I am from Sumitomo Corporation, which is a business-oriented firm. So I'd like to speak about how we have utilized quantum computing in the business setting by taking an automobile as an example. Firstly, let me introduce myself. So there's a fleet management team and QX team, and I am double hatting between these two teams. And recently, I also became the associate professor at Tohoku University. So the cutting edge technology business development is what I work on rather than focusing just on quantum technology. And I have worked on digital transformation in a broader sense. And what our company aims to achieve actually was presented by my boss, Mr. Okazaki, but this is a repetition. This is our corporate message. As a materiality, there are 6 of them, and especially what we placed importance on the 2 items on the left, and enriching people's lives. That's what we want to realize. And maybe this indicates quantum technology. This is the overview of our firm, and the number is interesting. 886 companies exist within the consolidated group. So we do aircraft business, and we have IT company. Also, recently, the offshore wind power generation is another business we have been conducting. So in areas close to your day-to-day lives, we also have business operating supermarkets. And in this building, there is a drugstore called Tomo's. So I purchased an item from that drugstore. This is a health boosting drink. And then automobile group is working on extensive domain of business. So we cover almost the entirety of the value chain of the automobile, and starting from the left. So especially in the area of software, we provide automobile companies through our engineering business, and also we support automakers in the procurement. And since we are a trading company, we also do the trading of finished automobiles, especially export to the Middle East. And also we do engage in service and maintenance. And also for customers who buy automobiles, we arrange financing and lease services. And at the same time, in the relevant topic, as a next generation business, in terms of utilizing automobiles, we have the parking lot business. In Europe, Norway, Finland, and Sweden, we do operate this parking lot business. And in this context, I have been working on digital transformation in a broad sense. And recently, we are now facing once in 100-year change, and people are calling for the shift to EV. So shift to EV and energy management are areas which I have been working on, along with car sharing. So mobility combined with healthcare is what I've been working on, and also parking lot business is another business. And what I'd like to introduce by taking this opportunity is now in the business setting. This is the actual business conducted in Stockholm, Sweden. So 100% EV is used for the car sharing business. So and a major newspaper run the articles introducing our business. Since we are a for-profit company, so we are looking at quantum technology as a tool. And on the left side, that's where we stand in terms of business domains. And we are adding the linear business, and then non-linear businesses will be relevant. But firstly, in linear business, evolutions, we like to apply quantum technologies to achieve improvement, and I'd like to introduce chips. So this depicts what we have achieved, not limited to quantum. First, 100% EV car sharing service. But basically, we have utilized our own experience and intuitions and to deliver ingenuity. And so, in a way, intuitively, we have worked on business environment. And recently, there appeared the context of DX. So we have made improvement of for aspects of marketing such as data analysis and customer interview. In a sense, we have utilized data to do what we do smartly, but as we look beyond what we are doing, we came to the idea of utilizing quantum technologies to deliver theoretical, logical improvement. And as the entire flow of business, we have worked on these things. First, what is it that we want to do? And then mathematical model is developed to resolve the situation. First, I'd like to explain the identification of necessary work. Firstly, as I belong to the automobile team, I worked on this business. So there were so many projects or businesses. There are about 800, and there were 100 or so of business domains. So where do we apply what? And when I think about that, the auto business basically is based upon the concept of traveling, whether it is bus or taxis, and the truck is one way of transportation. So the concept of transportation or traveling was the area where we would like to use quantum computing. When we break the traveling into components, it can be divided into run, stop, and turn. So if we can come up with certain solutions, we believed that such solution can be applied to various industries. So we started with traveling.
のを、一つ
We have decided on car sharing. This is our business, actually in Stockholm, Sweden. These are electric vehicles. You can use a smartphone to unlock and use the EV, and in the end, you can lock up using a smartphone and return the vehicle. So basically, the total transaction can be done on the smartphone. Where did the customer get on? Where did they get off? All the location data is also on the mobile phone. This is a very data-rich business, and we decided that this would be the easiest for us to start with. That's why we chose car sharing. And then we had to figure out which operation to target. For car sharing, the first two factors that you would think of course, is the two on the left on the slide. We have customers and also EVs, 100% electric vehicles. But we had to expand our scope. Well, they were all electric vehicles, which means that we needed to have chargers for these vehicles. And also cleaning was necessary, which meant that we also had to have operators or service personnel. And we decided to focus on the behavior or the movement of service persons and optimize it. It would be possible to make a different proposal to the customer, but using a mathematical formula, solving the issue, we decided that the service personnel would be easier to control because they were our own employees. So we have decided to focus on the service personnel and use quantum computing. Expected business impact is explained here. I wonder if you have visited Stockholm. Maybe some of you in the audience have. The operators' work is very tough. This is a Yamanote Line train track overlapped on top of a Stockholm map. And this means that in this business, car can be left anywhere within maybe half of the area of Yamanote Line. And in Europe, you don't have to park in a parking area. You can just leave your car by the side of the road. And the area is vast. And there is only a handful of operators to charge and clean all the vehicles, and then maybe drive back the car to where there is a higher demand. So this was a very tough operation. Let's say there are 3 service personnels, and this was the size of the revenue. If we can increase the efficiency with just these 3 operators and generate more revenue, then the business itself can be more profitable. And out of charge, battery being out of charge is a very big problem. If the vehicle is out of charge, it cannot run, it cannot be used by our customers. So how efficiently can we charge these vehicles by the same number of people but more efficiently to generate revenue and in the end profit? This was the expected business impact for this trial program. We had our internal team, and also in addition to that, we found every FI team from Tohoku University interested in car sharing, consisting of about 5 people. And we decided to collaborate and turn this problem into a mathematical problem and solution. And this is the overview of our consideration. Tohoku University prepared the mathematical model, and we provided explanation in great detail about the business logic. And then we ran the cycle of modification one after the other. Now, according to Tohoku University's team, usually a company is not forthcoming with the data, but our company was all about business and operation, and as long as the data generates revenue, we could provide the data. So we could disclose the data, the actual situation, and then Tohoku University could build a mathematical model based on that. So the data was really raw. You could almost sense the presence of the users or the actual vehicles. You could almost smell them from the data. And then the mathematical model was generated and it was used. First of all, we had to clarify the operation. We had to define what the tasks were. We wanted to maximize the optimization of the movement of the operators to maximize the revenue. So when the instruction goes to the operator, in many cases, the president will just say, just to send them to the ground and let them figure it out. But we have to define what measures we use in order to decide where the operator should go first. So we compare the distance between the chargers and the vehicles so that the empty battery vehicles or close to empty battery vehicles can be moved to the closest charging station. So far is bad and near is good. This is how the mathematical model was defined. So 0 is a route that is not used, 1 is the used route, and 4 variables were defined. And based on these 4 variables, the evaluation function was defined. If there are too many variables for quantum computing, sometimes the problem cannot be solved or it will take too long to solve. This is something that we have come to understand. We already had some business logics. So using the business logics, we've decided to reduce the number of variables through communication with Tohoku University. Some of them were difficult to visualize, but let me explain the simplest thing. For example, if the car is already fully charged, it doesn't have to be moved to a charging station. So this variable can be deleted. And in a similar way, we try to reduce the total number of variables to make the problem solvable. And this was the outcome. This was just a simulation, but the 26% improvement in operation was achievable. This is huge, close to 30%, and this is directly translated into profit. So I believe that this result was very positive. In the past, we relied on our experience and intuition, but now we could optimize 26%. And as you can see on this map, this is how the operators were moving. Green shows charging stations. Yellow is low battery charge, and red is fully charged. Sorry, green is fully charged, and red is low battery. So what is the optimal route? This has to be calculated dynamically while the different users are driving and the position of the vehicle is changing all the time. So the operator has to also respond dynamically by using the optimal route. And this can be calculated using quantum. Now, we wanted to solve the problem of transportation with quantum computing, and we have multiple businesses that can enjoy the benefit of this. So we will try to apply them to those businesses. Thank you for your attention.